The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and thanks for joining us for today's presentation. My name is Andres Velez. I'm the product manager for the AutoTURN family of products, and today I'll be presenting you the SmartPath tools, how to use them, what are their advantages, and yeah, in general, why would you want to use these tools. Before we start with our presentation, a couple of housekeeping items. This session is being recorded. You will receive the recording after the presentation is done, and the video it's kind of processed. We will have a Q&A session at the end of today's session. If you have any questions at any point in time, feel free to enter these questions in the questions section of your GoToMeeting interface. I'll be addressing them at the end of the session. So with that, let's begin then with our presentation, and let's take a look at our agenda for today. So today I'll essentially be showing you the benefits of using the SmartPath tools, and to contrast or better illustrate these benefits, we'll be talking a little bit about the traditional swept path checking methods. From there, we'll see, well, or it'll be very clear why to use the SmartPath tools in AutoTURN. We'll also take a look at some theory behind how we create simulations in the software. So we'll take a look at the vehicle path, how it's generated in AutoTURN. We will get a better understanding of the turning behavior and how speed influences the turn or the simulations we generate using the SmartPath tools. And we'll see some of the highlights. For those of you that are not aware, the SmartPath tools are an entire set of tools that will let you simulate vehicle maneuvers based on the position you indicate with your cursor or your mouse. However, the toolset comprises of three main tools intended to help you model or simulate different conditions. So we'll take a look at those, and that will be also part of our technical demo. We'll see some examples on how to use all these tools. Then we'll jump into our Q&A session. And at the end of this session, as usual, we'll have our survey, which is very important for us because it lets us excuse me, it lets us or it gives us some understanding about how valuable the session is for you, and if you're interested in seeing our topics or have other concerns, then we can definitely take those into account for upcoming webinars. So please, at the end of the session, take your time to complete this survey. All right, so let's jump right away into the traditional SmartPath checking methods. And of course, the first one are the turning templates. And turning templates, as you know, those are the ones we will find in design guidelines such as AASHTO, NACTO, NCHRP, or even local guidelines or local policies produced by departments of transportation or provinces if they're in Canada. And they have, or they may have, variations to the design vehicles in the main guideline. And essentially the way they capture how these vehicles turn is through turning templates. So what you'll see in a turning template typically is, the design vehicle and different preset angles or different types of turns and the different radii for curb to curb, wall to wall, center line, or even inner turn. For those of you that are not aware, design vehicles are typically um, larger vehicles are intended to represent most of the vehicles within their class. Let's talk about some of the limitations of this traditional swept path checking if we use the training templates as they are in the guidelines. So in most of the guidelines, these templates are generated based on a fixed low speed. So there's no variation. It's just sometimes they indicate, and the speed can be around like between 5 to 10 miles per hour. Some design guidelines indicate ranges of speed, so they'll have a template that works for 5 miles per hour, another template for 10 miles per hour, another template for 25 miles per hour, and that way, yeah, they'll account for different turns at different speeds. When we see AASHTO and TAC in North America, they used a fixed speed to create this turning templates. The speed that is fixed is low speed, so under 10 miles per hour. And we have the fixed sweep angles for all the different turns. These turning templates account for road conditions. They're typically just dry road conditions, but they won't let you simulate vehicles going on a gravel road or wet road conditions or slippery conditions. For those conditions, you will need to know the friction coefficient. You will also need to know super elevation. These templates are not really modeling any other road conditions than dry conditions and no super elevation. But we know super elevation plays a key role at vehicle turning, probably not at a low speed. It's not that significant. But once we go over certain speeds, they will start influencing how the vehicle will turn. We might be able to turn tighter depending on the super elevation. And I guess the other key element of this turning templates is they don't really support reverse maneuvers. If you try to generate a reverse maneuver based off a turning template, it'll be very, very challenging. So The challenges of using these turning templates are essentially these are the limitations. Scenarios such as the one you're seeing on this in the screen right now are very, very challenging because the vehicle is not turning at a fixed angle, and it's certainly not turning at one of the angles we saw in the template. So all in all, if you're using turning templates to assess this kind of scenarios, or scenarios involving reverse maneuvers, or where the sweep angle is not a fixed sweep angle, you'll find those very challenging if you're trying to use the turning templates as they are in the guideline. The other key element we should mention at this point is that vehicles in design guideline, because they're design vehicles, they're intended to represent most vehicles using that road infrastructure. Therefore, more advanced vehicles such as wind blade trailers or super long trailers that have rear steerable axles, you won't find turning templates for those. The manufacturer will provide you with the turning characteristics and a turning circle, but trying to replicate the maneuver of those vehicles using a turning template, or trying to come up with a turning template and to do the maneuver, it's even more challenging than the scenario we're currently seeing. All right, so this is our first method. Our second method is being widely used, although it has its own challenges, and it's following predefined geometry. So it's a pretty manual method in a way that it requires the designer to draw the intended centerline path using just your CAD software, and then, well, the vehicle will run over that predefined path and will be able to assess the off tracking. I guess the limitations, or some of the limitations for this type of analysis, or if you follow this type of analysis, is you'll need a lot of experience, or the designer will need a lot of experience to indicate the intended centerline path, because you're kind of like guessing where the vehicle should go and how it should make the turn, or, well, your ideal path. The first thing that will come up is that not all vehicles follow the same path, or will be following the same path. Larger vehicles will do different maneuvers than smaller vehicles. So it can be quite challenging to come up with a predefined path that will work and will make sense for all these vehicles. So a lot of experience will be needed for that purpose. The second key element to keep in mind when you're using predefined paths is that when you generate a simulation using AutoTURN, there's no speed for that simulation, or what we use in the software is a very low speed, about 1 mile per hour. And essentially all we're doing is checking the turning characteristics of the vehicle versus that path. If for whatever reason the vehicle cannot follow the path, then, as you know, the simulation will stop, and we'll see an example of that in our technical demo. But the biggest or the key aspect of simulations using, or created using reference geometry, is that they don't have a speed. It's just the turning characteristics of the vehicle. So depending on the centerline path, the vehicle might be going faster or slower, but that's not going to be part of the simulation at all. So one important thing there for you to keep in mind, it also doesn't account for any lateral friction or super elevation. There's no steering rate, and we'll see what that means in a minute. And finally, the another key limitation of simulations created following geometry is that they can't really simulate reverse maneuvers. So all you're doing is simulating the vehicle moving forward. There are ways to generate reverse maneuvers if you're using predefined geometry by switching to SmartPath Tools. And again, we'll see that during our technical demo. But this illustrates the limitations of both methods, or the most traditional methods. And now let's talk about the SmartPath Tools and why to use them. So the SmartPath Tools allow you, or calculate the vehicle path, while at the same time accounting for the turning characteristics of the vehicle, the speed, super elevation, and lateral friction. And what that means to you is that AutoTURN will produce realistic results. all these calculations are done on the fly in the background for the software. So if you're changing your speed, AutoTURN will, based on, well, you will see the relationship soon enough, but there are two equations that the software is dynamically checking. One is the turning characteristics of the vehicle. The other one is the speed equation, as you know from ASHTO, which is essentially just the circular motion formula adjusted to, well, have some comfort for drivers while on the road. And AutoTURN is constantly checking these two for the design vehicle and calculating which one is the largest one to dictate the minimum turn radius for the simulation. That's all done in the background. That way we ensure the simulations you're producing make sense and you're not creating things that are unrealistic, such as tight simulations going higher speeds. So in AutoTURN, it's part of our core algorithm. We won't let you produce those kind of unrealistic scenarios. Uh, just to contrast to what we also saw in the turning templates or from the turning templates, we will be able to just try the vehicle the way we want it to drive while accounting for these characteristics and produce different types of turns, not necessarily at a fixed sweep angle. There are tools in the software that will let you indicate the sweep angle if you want to, and we'll see them during the technical demo. And they also, or the software, the SmartPath Tools will also let you generate reverse maneuvers, such as the one we're seeing in the screen. And as you can imagine, trying to generate just, well, something as simple as this using the turning template will be a lot more challenging. And if we try to use centerline geometry as well, we'll be kind of guessing where that magenta line should be to accommodate this vehicle. And then if we have a different vehicle, something larger, say a WB67, then the path will likely be very, very different because of the difference in size. So the SmartPath Tools will save us from all these types of guessings or overlaying the template several times to try to get around. Okay, so as I mentioned before, the SmartPath Tools have different modes, and each mode is intended to help you generate different types of maneuvers for different types of vehicles. ArcPath mode is the simplest of all. It essentially generates a simulation or a path that comprises of two elements. One is the transition portion, which we'll see in a minute, and the other one is the circular portion of the path. That circular portion of the path is determined by the turning characteristics and or the speed. And you will see how that relation works in the software. But it's the simplest of all. Essentially, this is the trajectory or the path the vehicle is um, uh, or generates as you drive with your mouse. Corner path, and they all use the same core algorithm, but corner path is really intended to help you design movements where the sweep angle is known. If you know you're creating or simulating a vehicle at an intersection, then corner path will let you do that and specify the sweep angle, and and you'll be able to control where the vehicle is going. You'll have editing capabilities beyond ArcPath because the simulation will be a little more complex. And then oversteer corner path, which is based on corner path and ArcPath, again, will generate an oversteer maneuver, which is what typically large vehicles will do. So semi-trailers, particularly WB62s and 67s or WB19s and 20s, if you're in Canada, will oversteer to make corners. That means the vehicle will encroach the adjacent lane at the entry or at the exit. So, and to be able to kind of clear the curb or make sure the trailer doesn't go over the curb. So all these three tools, you'll find them there as a set in AutoTURN, and depending on the design scenario and the design vehicle you're using, you may want to use one or the other. Okay, so we touched a little bit on the path. Now let's talk about how we generate the path in AutoTURN. And as I mentioned, when you're doing the SmartPath Tools and particularly ArcPath, you'll find a transition portion and a circular portion. The transitional portion is that section of the path that is required to get the wheels from the starting steering angle, which is say a straight line, to the steering angle required to execute the turn. And that transition portion of the path, I'll explain later how it's calculated in the software, but it's based on the steering rate, which is also based on the lock-to-lock time. In AutoTURN, the lock-to-lock time by default is 6 seconds, and the reason for that is in our own field tests, we have observed that skilled drivers will crank the wheels from one direction to the other in about 4.8 seconds. But because with design vehicles, our intention is really to mold average drivers. We want to be a little bit more conservative in this sense. So that's why the default lock-to-lock time for that transition portion of the path in AutoTURN is 6 seconds. And that also helps AutoTURN match design guidelines, so on and so forth. And then after the transition portion of the path, we have the circular portion. And at that portion, or for that portion, the vehicle is turning at a steady state. This is essentially just describing a radius going around a curve. And that radius can be the minimum turn radius, or it can be just the radius required to make the turn based on your cursor position. So I'll explain that also later today. So we have our path. This is how it's created. And now let's talk a little bit more about the transition portion of the path. So as I mentioned before, for low speed, this transition portion is based on the steering rate. And that steering rate is determined based on the lock-to-lock time in seconds. So when you have the lock-to-lock time and you have the speed of the vehicle, you can calculate how long this transition portion will be. And for that length and the speed, you can calculate the steering rate. So how much does the wheel or do the wheel need to steer for each section until it gets to the steering angle required to execute the turn. The implications of the lock-to-lock time is that it'll make your transition portion longer or shorter depending on the time. With our default, you can see the first picture there is using 6 seconds lock-to-lock time at a speed of 10 miles per hour. That's the turn you'll get. If you keep the same speed, but you almost triple the lock-to-lock time, you get a transition portion that's a lot longer. For higher speed, however, and I mentioned that AutoTURN checks the behavior for low speed and high speed as well. In high speed, we use the rate of changing lateral acceleration, just as is captured in the AutoTURN design guideline. Now let's talk about the circular portion of the path. And once again, the key element here is the speed of the vehicle. So AutoTURN is being field tested for low speed. Then since we match the turning templates which are also generated for low speeds, that's kind of like AutoTURN's core functionality. When it goes higher speed, then we use the speed equation formula as you have in AutoTURN. When we are at low speed, the minimum radius for the turn is dictated by the steering lock angle of the vehicle, so how much you can crank the wheels, and the wheelbase. So the radius will be a function of wheelbase and the steering lock angle. Once you go higher speeds, say over 10 miles per hour, then we use the speed equation from AutoTURN where the minimum turn radius is dictated by the relationship between the speed, the friction, and the super elevation. And this is, as I mentioned before, it's just a circular motion formula calibrated for comfort for drivers, trying to make sure curves designed based on AutoTURN are comfortably drivable for users. So AutoTURN is constantly checking these two elements. Depending on the wheelbase, it'll start using the AutoTURN formula at a different speed. If you are, say, at 10 miles per hour, but your wheelbase is big, the vehicle might be using the turning characteristics. If you have a short wheelbase, then you might start using, or AutoTURN will start using the AutoTURN formula earlier, say at speeds over 12 miles per hour. So that behavior is reflected also by the SmartPath tools. You will see as AutoTURN starts using the ASHA formula, then you have control over super elevation and lateral friction to create or adjust your simulation and enter road conditions that at that point are starting to become relevant for the simulation. So this should give you a good understanding of how AutoTURN works and how it generates the simulation. And now let's jump to our technical demo, and let me show you some examples of why it's key to use the SmartPath tools. Okay, so let's see AutoCAD. Let me just open my drawing here. Want to make sure you guys, yeah, can see the drawing. And now let's launch our intersection first. Okay, just taking a couple of seconds to load. All right. So as I mentioned before, all the traditional methods are well, we could use different traditional methods to run our simulations or to do our analysis or subpath analysis, but depending on the design scenario, using them or using one of the traditional methods might be very, very challenging. So right now we have an intersection. We know a template will work or will help us simulate vehicles here. However, if we're doing something that involves reverse or more complex turns, we might run into trouble, or it might be too complex for us to simulate or model. So AutoTURN is also capable of generating turning templates for design vehicles, if that's what you would like to use. So if we say OK to this, let's just launch AutoTURN Pro. This is the latest version of the software. So if we want to, okay, so well, for those of you that don't know, it's very straightforward. We just pick the design vehicle we like to use, and then we can generate multiple templates. So say for instance, and I'm going to use the WB40 for this simulation. We have here all the vehicle or design vehicle with all its dimensions. You probably notice I'm using AASHTO 2018, so we already have the latest version of the design guideline. If I say OK, and if I'm only interested in using a turning template for my analysis, I can generate it here. And a couple of things for you to notice while we're here in the turning template option in AutoTURN. We have control over the different angles, sweep angles we would like to use. So if we're only interested, say, in a 90-degree turn, although for this intersection we're not 100% sure this is a 90-degree turn, but that will be the closest, we can just uncheck all the other angles and use that. Depending on the analysis, we may want to use specific or check a specific radius type. Right now we're displaying the wall-to-wall. However, well, and here in the report, we can essentially just change how all these elements look like. I'm going to make everything black so that we can clearly see it. And then the achieved angle table. So one thing I would like you to notice is that display radii dimensions is only showing centerline and wall-to-wall. And the reason for this is because in the properties, I only have certain envelopes checked. So I'm going to go to my properties and show you. So right now, what I have is only the vehicle body envelope. If we don't use the tire envelopes, then we won't be able to see what the curve-to-curve radius is for that turning template. So if that's what we're interested in, we can check front and rear tires. I'm going to change the color so we can clearly differentiate between these elements. Say OK to that and go back to my turning template. Okay, so now we can see the curve-to-curve option is available for us to check it. And if I say place my template, now it's AutoTURN is generating it for the turns or the sweep angles we specified. Okay, and we got our turning template there. We can see what the tires are doing. If we take a look at the achieved steering angle versus the sweep angle, we can see what the steering angle is for each type of turn. So we can see this vehicle, and the steering lock angle for this vehicle is 20.3 degrees. So it achieves that angle at 120-degree turn. So beyond this point, it's at a steady state and it's turning at its minimum to achieve all the other angles. So that's what the template is telling us. We get all the different radii and its dimensions. And the other thing, I guess, important for you to note is that this matches exactly what AASHTO 2018 has in the guideline, because we helped them develop these templates. So AutoTURN will 100% match what's there in the guideline. And now, as I mentioned, if we were to use this template, you will have to use my CAD commands, rotate the template, um, and then start moving it around, trying to overlay it with this intersection. However, if the sweep angle is not necessarily the one we're looking for, we're going to run into trouble, or it'll be a bit challenging. Even if we were to do it here, although for a different vehicle at this drive-through, if we were to follow some reference geometry, say this intended centerline path, which is pretty obvious for a drive-through, which is this scenario that we're seeing right now, yeah, we might run into troubles just using the template. So to show you the second, or to illustrate the second point of our, or the second traditional method for checking swept path, if we have a predefined path that we would like to follow, then we can do that with AutoTURN. But you have the considerations. If you're only looking at a forward maneuver, then it'll work. But if we want to back up the vehicle or park it in any of these stalls, then the tool won't get us there. It'll only simulate the forward maneuver. If we need to control the speed or change it, the same idea. We won't be able to do it if we use this tool. So what I'm going to do now is I'm going to uncheck front and rear tire envelopes, just to make my simulation look a bit more obvious. And I'm going to select different design vehicles. For this drive-through, perhaps we may want to use delivery truck, and we have also the NACTO design guideline here in AutoTURN that we can use. For street redesign, or, well, it's got a nice medium-sized truck that we can check through this drive-through. So if we have predefined geometry, I can just use it. The tool is really intended to model either a center line as intended path geometry, or using curves. So in this case, we have a recurve geometry. They're just lines and arcs, as you can see there. And if I use place adaptive simulation, if I pick this geometry, you'll see I have to pick in the sequence I want my vehicle to travel. That's the first thing to notice. And the second thing you'll need to know is that this geometry needs to be connected end to end. Once we have selected all the elements we would like to use, I will click outside. And you can see by default is using center. The other key element you may want to make a note of is that the vehicle stopped there because it reached the maximum steering angle, or the steering lock angle has been reached for that turn. Of course, we don't want to use the curve as centerline geometry, so the tool allows us to do offsets and use that geometry with an offset. We can do it to the right, and then our simulation will go through. It's been pushed to the right. We can control the offset and indicate, well, 5 feet might be perhaps too much for a drive-through. We need to actually get the vehicle closer. So I'm going to change it to 1 feet. And now my simulation is closer. You can see, because it's following geometry just based on turning characteristics, it's oversteering here, which is not necessarily realistic for this vehicle. But since we're only following the geometry using the turning characteristics, that's kind of like the output. If we're okay with that, we can just say okay and leave our simulation there. In this scenario, because we already have a centerline path, I'm going to delete this and use the centerline path. And my centerline path I created as a polyline, or if you're in MicroStation, that would be a complex chain. So I can generate that simulation. In this case, I want it to be centered. You can see that I linked the simulation to the path geometry. So if I want to do little edits, I need to change the path, or the intended path, and my simulation will react to that. If I say okay to that, I got my simulation, and I guess the couple of things to notice, we can only go forward, and there's no speed. I never had a chance to enter a speed. So if I'm interested in modeling this vehicle with different speeds, or maybe coming in at 5 or 10 miles per hour, then slowing down to 5 miles an hour, making the turn. I won't be able to do that with the follow path tool. I'll be able to do other things I can, just to prove the point, I'll go vehicles. And I'm going to go back to ASH to 2018. All right. And now I'm going to pick a passenger and boat vehicle again for this drive-through. And I'm going to say OK to that. And if I click on the tool, well, the tool has some memory, and I could essentially just use the same path, see if this vehicle will go through. We can see it follows that centerline geometry, but the off tracking is different. However, because this is a two-part vehicle, likely the driver will oversteer to make that turn. In this case, we're assuming they will all follow the same path. So another key difference, we just stick to the path. All right. Now, I mentioned also that we can generate reverse maneuvers of place adaptive simulations because we can switch from place adaptive, so follow geometry, to the SmartPath tools. The way to do it is by continuing the simulation. So I'm going to click here in continue simulation, pick my simulation over here, and then just move it forward. And now you can see, because I'm in the SmartPath tools, I have control over the speed. I can check or uncheck different options, and we'll see through those, or we'll go through those as we advance in our demonstration. So what I'm going to do is I'm just going to make a turn here, and then if I want to, say, back up this vehicle, so I'm going to go, let's say, over there. If I want to back it up, I can move my cursor backwards, and that triggers reverse maneuvers. I can also trigger reverse by using this button here. And then if we are in the SmartPath tools, we can indicate, as I mentioned, the sweep angle. And in this case, sorry, this is a block, I believe. That's why it's not picking it. So what I'm going to do is I'm going to stop there for a second. Okay, and I'm going to draw a line here on top of this block that I have here in AutoCAD. And what this will do is help me guide the movement. So I'm going to continue my simulation again. All right, and now let's trigger reverse. Okay, now we're in reverse, and I can indicate the sweep angle that I want to target with my vehicle, and that solves my reverse maneuver. If we want to move or continue forward, then we're in the SmartPath tool, so it's totally flexible. We can switch between the tools, so arc path or corner path or steer corner path, we can switch and generate the out maneuver. Okay, so that's how you can switch from a follow path simulation to one of the SmartPath tools simulations. And let's move now to the intersection. And again, I mentioned if we use the turning template to make 90-degree turn here, if we're checking opposite turns, we could use the templates. But if these angles are not 90 degrees, it can be quite challenging. So first thing I'm going to do, I'm going to go back to my design vehicle. I'm going to pick the WB40 for this intersection. And what I'm going to do is I'm going to make a left turn here going south to west. So you can always launch the SmartPath tools by clicking on any of the different tools. And let me just explain why we want to use corner path for this one. So I'm going to align my vehicle with the geometry in my drawing. Once I have it there, so there's a couple of things that I could use. Well, I'll explain this later, why it switched. But I could drive this vehicle using just arc path, but likely what this truck will do, it'll go a little wider, say as on a tangent, then describe a circular path and then another tangent, because I want this vehicle to be aligned with this geometry at the end of the turn. So the best tool for me to use in this situation would be corner path, because it'll let me generate the maneuver. And you can see right now, because I was using it before, it already has the sweep angle for this intersection, which is not 90 degrees, it's slightly over 90, 96.6. We can use geometry or indicate or tell the software, well, for my sweep angle, or for the software to calculate the sweep angle, this is my reference geometry. So it's actually 95.9. It wasn't 95.6 as we saw before. And now my vehicle is aligned with that geometry. This is likely what the WB40 will do to make that left turn. I'm going to place a section there. And you can see my simulation is pretty straightforward, is smooth. I guess the thing we didn't check was I was using 5 miles per hour to generate the simulation. So let me just undo to show you the effect of speed here. So this is the previous angle. So I need to click my geometry, pick this. We're doing it at 5, so I can turn pretty tight. I could even go to the opposite direction, or against the traffic. If I increase my speed, this is going to affect my centerline turn radius. So I won't be able to turn as tight anymore. But if I'm using 15 miles per hour, that looks realistic enough for this turn. I'll just pick again my sweep angle so that my simulation is completely aligned with that geometry. And that's it. We can see the body envelope is touching the curve. Likely that's acceptable. We'll have to look at what the tires are doing. But sometimes the body envelope can go over our geometry. One solution for this could be like just push backwards the median, because the conflict is so small. In any case, for now, let's keep that simulation like that, and let's generate a different one, now going the opposite direction, because we're interested in seeing where we could have opposite turns here. So I'm going to use a smaller bus for this one, kind of like a bus, a school bus. And I'm going to start from the same position. I'm also going to use corner path here. Pick my geometry to align my vehicle with. Place simulation there. And I'm using corner path. I can also indicate that I'm keeping the speed the same. Make it come here. And it's looking so far so good. Okay, so large vehicles will likely use corner path to generate these maneuvers. If we're using a larger, or even a larger vehicle, say a WB62, we know that vehicle is going to oversteer. Right now, if these are our road conditions and these are the vehicles or the design vehicles we need to support for opposing turns, then all we need to do right now is check a clearance for the body envelopes, make sure they work. So to do that, we don't need to redo anything. We can just go to vehicle, to our properties, and specify body clearance. And for this type of intersections is about 5 feet clearance we need to guarantee. So if we click on it and update our simulations, we can see we're not really getting that clearance. So for these two design vehicles, it might not work. There are things we could do. We could try to fine-tune the simulations. We can see, well, here we're not going over the curve because we're using corner path. We get different options. So the options we're going to edit is we can adjust the radius. We can make it smaller. I cannot go beyond that point because that's the minimum turn radius for this vehicle at 15 miles per hour. So one thing might be, well, reducing the speed for vehicles. Another option will be timing, perhaps timing the traffic lights so that we don't have opposing turns. So I have kind of like come as close as I can to this median here. I may even want to like push this median backwards. I could make this vehicle oversteer, but it's not likely what the boss will be doing. So I'm going to leave that simulation like that. I'm going to try to edit the other one here. And this vehicle might oversteer, but it's not going to help us for this scenario. So once again, it's already kind of turning at its tightest, so I have no control over there. I can adjust the offsets and make it oversteer if I want to get it away from my median, if I don't want to run into any construction work here. And you can see how I have triggered an oversteer maneuver, which is likely what this vehicle will do if the space is that tight. Or in this case, it doesn't really need to do it. If it was a larger vehicle, we'll probably need to go over the adjacent lane. So to show you that, let me just create a simulation with a larger vehicle. So I'm going to delete this one so we can see it clearly. Let me uncheck my clearances because we know if it doesn't work for WB40, it's not going to work for WB62. But we can try this vehicle, see if it will go around the intersection. So this vehicle might oversteer because it's way bigger than our previous one. So again, I can pick the geometry to align it. I'm going to push it forward, and then I can generate my oversteer maneuver. I'm going to select my sweep angle again. I might need to do it at lower speed. So you can see at 15, we won't make the turn. So I'll have to lower the speed. I'm going to try 5 just to get around with the simulation. And you can see it really needs to oversteer. I can control the entry offset, make it as small as possible, even 0. That means it'll stay away from the bus over there. But my exit offset is already at its minimum. So I need like 5 feet. So it's going to take both lanes to make the turn. Similarly, once we place it, then we get the same controls to change the offsets, or to control the offsets and control the turning point and orientation, and even the articulation of the vehicle at the starting position. Okay, so we have different controls. The most relevant for this scenario will be the offsets for sure. And you can see it's quite constrained for this vehicle. So in this case, WB62 will be very challenging unless we time the intersection. For larger vehicles, the recommendation will be to use corner pad or oversteer corner pad, depending on how large that vehicle is. And you saw the effects of the speed. Let's take a look at what a smaller vehicle will do. So a passenger vehicle likely won't make a corner turn. So for those, we have essentially arc path. And this vehicle will likely be describing this trajectory. It will go a bit faster. So we can try 25 miles per hour, for instance. And that's pretty much the speed limit. And yeah, when we go to 25, you can see there's a big spiral there. If we use the preview paths, we can see it can only turn so tight for this intersection. So we might want to lower it. 25 was way too high. You can see now the changes in the whiskers. We can see based on the current position, the speed, how tight we can turn. For this vehicle, it's simple enough. We don't really need to do that. We can just jump into the turn and generate our simulation there. And this is likely the trajectory this vehicle will be describing. If we need to undo, I can click on top of the steering axle and then generate a different section and keep going. Right now it needs, you can see the effect of the spiral kicking in because we're at 15 miles per hour. So I cannot just crank the wheels in the opposite direction and change the turning. Okay, so two very good use cases for the SmartPath tools. The third one, and for that I'm going to go to this loading dock scenario, is reverse maneuvers. So for reverse maneuvers, we know the SmartPath tools will let us simulate or generate reverse maneuvers. If we go and pick our WB40 that we were using before to access this site, we can control the speed. So let's say if I'm coming from, oh, sorry, I placed the vehicle wrong. So what I'm going to do is I'll move it. And for that, I only click on top of the vehicle. So if I'm coming into this side, then I'm using the road. I might be coming now truly at 25 miles per hour. I can generate a section like this, but before making this turn, the vehicle will likely slow down a lot. So I'm going to lower down the speed to 10. And then make this left turn. Now, given that I'm not taking the adjacent line, this vehicle might oversteer, and I can use geometry to guide my movement. So I want to make this turn and have my vehicle more or less aligned with this. So now AutoTURN is like solving it for me. I can come back later and edit the path can generate that first section, and now I'm going to go around this area. I don't need to oversteer anymore, so I could try to use corner path and use geometry to guide my simulation a little better. So now I want to have it aligned there, and go switch to arc path and even lower down a bit more. So I'm going to go 5 miles per hour now and try to drive this vehicle around. So here, when I'm coming to the tight space, is the only situation where we recommend you to check the turn wheels and stop. What this option means is that we will suppress that transition portion of the path and assume the vehicle is coming to a complete stop and cranking the wheels in the other direction. So you can see currently I have a section there, so it's not so easy for me to change direction. I need to use the lock-to-lock time and the steering rate before, right, or to generate that transition portion of the path. If I want to turn it on the spot, then I will use the turn wheels and stop option on, and I can change right away. We only recommend this again for this type of scenarios when you need to turn tighter and you're doing low speed. You should still try to keep your envelopes very smooth, because that's realistically what will happen to the vehicle. If we just go like this and we have a jagged envelope, likely a driver won't be able to do that. So when you're using this option, you should still try to keep your envelopes as smooth as possible. And we can make this turn and go around here. And let's see if we can park from here in these spots. So I'm going to push this backwards. And another key element of the SmartPath Tools, it'll let you steer from the first part. So you have two reverse modes. The first one is the traditional, where you're just dragging the trailer, and depending on how tight you're going, you can see the outswinging. If we go corner path, again trying to guide our movement, we can pick geometry in our drawing and align the vehicle to that. And you can see the outswing right there. So that might not be a desired situation for us, although we can see that we can solve the simulation for the spot. So the vehicle might be able to make it, just needs more space. If I switch back to arc path and I check the steer from first part, now I'm controlling the tractor. So this gives me more control over the outswinging of the vehicle. I can try to back it up from the first part, and you can see I'm not going as wide as the previous one. So if you do know how to reverse semi-trailer, this tool might be very useful for you. Try to get the vehicle into the spot, minimizing the outswing. So with the SmartPath tools, we can do this. We can pick the reverse method we would like to use to drive our vehicle to the desired spot. So we can go from there and continue driving backwards until we get into the spot. You can see by now I'm pretty much aligned to the stall I want to use. So we can switch and use one or the other reverse method to accomplish this type of maneuvers and generate sections. Let's say I managed to park it there and it's in good track to do that. Once I move forward, you'll see the option is checked by default. It's because, well, the first section after a reverse section, the vehicle is coming from a complete stop and then moving forward. So it'll be checked, so be aware. If you're, again, just trying to exit, you may want to uncheck it for the next section so that you have that spiral portion incorporated into your path. And one last thing I would like to show you before we jump into the Q&A session is more complex vehicles. So we mentioned turning templates only support the most basic, or well, the most commonly used vehicles, and it makes sense because we are using those for design. But whenever we need to simulate or try more complex vehicles, turning templates might fall short, and it'll be very, very hard to replicate what these vehicles can actually do. So I'm going to pick a wind blade trailer here. This vehicle, although it follows Ackerman's principle, which is AutoTURN's core algorithm, has steerable axles at the back. So it turns a little different. I'm going to align this thing with my geometry, and we know this is a fairly big vehicle for this intersection, so likely it'll be driving not in the left lane but in the middle of the road. And you can see right now my axles are steering, the rear axles are steering, and this is based on the steering linkages that we define for this vehicle. I can bring it up to this point, but you see if I continue, my axles eventually are going to go over my median there. So these vehicles usually have the option of for the driver or a second driver to control the steering of the steerable axles. You can see now that I switch, they're going all over the place. They're not steering because the control of the steering is all on me. So if I try to go like this, actually I'll switch back to this one for a second. So now they're steering based on the steering linkages, and that helps me model or clear that first curve. If I continue that way down this road, you see it's going to go over the median. So I may want to turn on the manual steering mode. I'm in control of what the axles are doing, and if I press the control key and use the scroll wheel in my mouse, I can control the steering, and you can see the steering angle for the rear axles is changing as I scroll. And now I'm clearing the median. Oh, sorry. Yeah, I need to keep pressing control, otherwise it zooms out. We can continue going. By then we can like clear it. I'll place my section there. Body envelope for this vehicle is high enough. If my option is still checked, they will continue to be steered at 35 degrees. But from this point on, I can go back and use the linkages and continue driving. So this is something that only the SmartPath tools will give you. And these are all the advantages. I would like to stop there, the technical demo, go back to the presentation, and also to talk to you about IntelliPath or introduce IntelliPath. So all these methods will give you different benefits. When you take a look at IntelliPath, and that's our upcoming webinar, you will see how in AutoTURN Pro now there's an option in which will just generate the simulation for you. So you don't even need to worry about the speed or how it'll turn or which tool to use. IntelliPath will sort of figure out that for you. So if you guys are interested, I'll invite you to come to our next webinar, which will happen a month from now, and we'll show you how IntelliPath works. Okay, so with that, let's open up for our Q&A session. Just for your information, these are the upcoming webinars we'll have this month and next month. Taurus or Runabout tool will be showing you fastest path analysis on May 23rd, how to generate that using our Taurus or Runabout tool. On June 6th, we'll have our Nexus DDI, Divergent Intersection Design tool. So Divergent Diamond, I'm sorry. Intersection design tool we recently released, and June 19, as I mentioned, IntelliPath and how it can be used for things like traffic calming. All right. Now, if you have any questions or general inquiries, you can send us an email at info@transoftsolutions.com. If you have sales inquiries, there's our sales email, and technical support. Here you go. If you have technical questions, feel free to contact me. Here you have my email. And thanks so much for attending. And